welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice. I'm a host at House of ZK. I'm joined here today with Sylve from Hyli and also Clement from Kakarot for the Hyli and Kakarot special. So we'll be talking about how both Hyli and Kakarot are working together to enable client-side proving, some of the new applications that can be enabled, such as those that are privacy related, and how any audience members, like any developers or users, can get involved. So I wanted to first start off, if you two could give an introduction about yourselves, but also some of the new updates relating to Hyli and Kakarot. I believe the last episodes or podcast episodes that we filmed together were from around a year ago. And since then, I'd like to hear about some of the new updates, some new changes that have been made, especially, on Kakarot's side, how Kakarot has adapted to some of the changes in the Ethereum ecosystem, and how you guys are working with the real-time proving with ETH proofs. And then on a Hyli side, your guys' pivot to the L1. So I wanted to hear some of the kind of the new updates and the direction that both teams are working on right now.
Sure. Should I start? Because you mentioned Kakarot first, so anyway, I'll do. So on the Kakarot side, so mainly we have been building for almost 3 years now Ethereum clients. So the initial goal was to be on the ETH-proof race with an Ethereum prover. I would say that was built with Starkware stack in Cairo. What happened in May, actually, as everyone knows, is that the Vitalik first and then the Ethereum Foundation started to open the Pandora box of basically removing the EVM as we know it, as it is today. So making basically the work that we had done a bit pointless in a short-term future, I would say. Given this new situation, we have gathered the knowledge that we had about the Cairo VM, which is supposed to be like the most efficient zkVM, but maybe not efficient enough for a big program like the Ethereum state transition function. Maybe not efficient enough for a program with a given set of attributes, I would say. So we had a strong expertise on how the optimal minimal zkVM works compared as opposed to what is actually working now, RISC-V based VM, U32 or bytes based VM, I would say. And given this situation, we have decided to just restart from scratch a new zkVM that would allow us to get especially very strong performances on consumer devices. So I think that it's still the case, but it was even worse in May. All the contender on the ETH-proof platform were actually using GPUs, mainly GPU farms. And I remember that at some point, Risk0 posted on Twitter something like, "We are very proud to announce that we have bought a new 150K GPU cluster that will allow us to be the first to real-time proof Ethereum." So at some point when you see that someone is just bragging themselves just to 150, this is not the numbers that we are used to look at when we consider hardware required for Ethereum. So back in these days, we said, okay, we need to pause the client. We are still committed to Ethereum. We know how to make a zkVM. Let's make something efficient for client side. And this is how it started in beginning of June, I think. And so doing so, we started to explore a different application of client-side proving. And interestingly enough, in this same time, the debate in the European Union was strong and is still strong for the zkID, privacy preserving ID solution for blocking social network application like TikTok or porn website. Or the zk is supposed to be integrated in the European wallet in 2026. Google made a public implementation of a Ligero-based protocol, and they pushed it to the official European Union GitHub repository. There is an official European Union GitHub repository. So they pushed it to the official GitHub. Anyway, so there was a strong push for other kind of ZK application based completely on local proving. And so we have been sort of at the crossroad of these two directions. And so since then, we are building a privacy I would say privacy first solution, ZK based privacy first solution, and especially, and maybe we'll talk about that later. Or I'm personally a big fan of ZK login. Or I mean, I'm a hardcore believer now. It's like a hardcore believer that the private keys are about to be completely removed from end users. The end user will just generate proof. Everyone knows that key management systems are a mess. And so, of course, the users don't want to do it. And it's no surprise that it's been 15 years that crypto exists and the private key thing, the seed phrase thing is still an issue. So I think that zk will solve it.
Yeah, absolutely. And it's yeah, really great to hear about kind of the reasoning behind some of the pivots that Kakarot made. And originally Kakarot was a ZK-focused EVM solution, but now you guys have pivoted to a more general purpose zkVM that is focused on strong performance, specifically with these consumer devices. And so it's really exciting to see the new direction that you guys are going to. And Sylve, on your side, I'd love to hear some of the more newer updates relating to Hyli as well.
So we released the testnet in July, and the vision that we've had for Hyli was always to how can we build a blockchain system that makes it as easy as possible to really milk out all the efficiencies that you have thanks to ZK. So you usually have the usuals of ZK-based application can bring you privacy, bring you scale, but the one part that was always in the back of our mind was precisely what you were mentioning, Clement. It actually makes it easier for users to use blockchain because they can use existing documents that they have in order to log in. You can send, currently using ZK, you can send money to someone's email address. And that is just incredible because they are, I don't know, maybe a couple million people currently on blockchain that went through the problem and the ordeal. We talk about onboarding someone to blockchain. It's like you have to access this ecosystem. And ZK just breaks down the barrier between Web 2 and Web 3. So that's just overall the very exciting thing that we've always seen. And that's why Hyli is a very, very opinionated blockchain network. We just do three things quite well. We have fast consensus, scalable DA, and we give a lot of leeway to developers and users because we don't execute anything, which is verified proofs. And so that's why we were very happy to work with Kakarot because we've implemented Kakarot, their proving system natively as part of one of our proving system. Clement, can you mute yourself? There's a bit of a background like crushing thing. Good, perfect. That way I only hear the sound of my own voice. And so it's just really cool. Most of the work, as Clement said, in the ZK space has been spent on what I would call server-side proving or GPU proving, because the main motivation and incentive in the ZK space, we had like so much funding and so much research done on the ZK space, in the blockchain space, because we wanted to scale blockchains, and blockchains run on servers. And so now we have like incredible things such as zkVMs, etc. But it means that you always kind of have like the smallest sibling, which is client-side proving. Oddly enough, in the blockchain space, we've started with client-side proving because we had Zcash. Zcash being the first real ZK blockchain application. Funnily enough, Eli Ben Sasson from Stockware was also involved in Zcash, so he went through it all. And so I'm really glad to see more client-side proving applications come back into the fold, specifically with systems like Kakarot, because we've had so much research, so much good work done on server-side proving, and I'm very excited to see new proving systems like Kakarot, Ligero, or Ligero, I don't know how to pronounce it, come over here. And on the Hyli side, like we released testnet in July, and we're always happy to implement new proving systems in order to implement them directly on the Hyli and give it access to applications and builders.
Yeah, sounds great. And it's really good that you also mentioned you see ZK as this kind of tool to break down the barrier between Web 2 and Web 3. And now in terms of just like onboarding kind of new developers or new users to Web 3, that process, or at least the learning curve there, can be like a lot less steep. And to your point on most of the work so far has been spent towards GPU-based or server-side proving, and because of that, we now have like lots of developments in, say, zkVMs and just some more developments relating to the scaling side for zk. But you do mention also that the smaller or more like neglected sibling being client-side proving there as a result, but we are seeing some of these like new developments being made on the client-side proving side. Just on that topic, just on the topic of how zk has mostly been used for these scalability purposes in the last few years, we've seen, for example, zk being used to scale rollups, but only recently we've seen some more privacy-based zk applications that can be enabled with things like private-side proving being developed, like with identity verification, for example, with private transactions. Were there any kinds of, like, from both of your guys' end, I'm curious to hear if there's any kinds of notable developments that you saw that helped facilitate this shift in focus? And you mentioned, Sylve, that our origins here originally were privacy-based, like you mentioned, for example, with Zcash, and then we've focused a bit more on the scalability aspect. And right now we're going to look back more into privacy with client-side proving. So curious to hear from both of your ends if there's any kinds of notable developments you saw that helped facilitate this shift in focus, and if you have any kinds of general predictions on how zk will predominantly be used in the future or be catered to any kind of specific applications.
I can go first. I have an idea. The main driver for everything, you could probably sum up the past 10 years of zk research as going from cryptographers to developers. It used to be that you needed to have a PhD in cryptography to do anything. And to the Zcash team credit, they built an actual proving system that could be used by the hoi polloi. It's very difficult to use, but you brought down the barrier from being Elie Ben-Sasson, having a PhD in cryptography, to just being a very, very good dev. And you had the same thing again with Circom, which was another, I'm going to say, tooling development kit to generate client-side proofs with a proving system called Gross 16. And currently it's still the one that is most commonly used. And so in terms of the most recent development that have really pushed the envelope for client-side proving, I think Noir from the Aztec team has really, I would say, rekindled a lot of developers' relationship with client-side proving, because Circom is still quite difficult, but Noir is easier. I will let Clement say if it's easier than Cairo. But overall, I would say, as seen from our perspective, because we do support Noir, for a long time we had been advocating to devs that if they want to do something client-side and really prototype it quickly, we would advise them to do it in Noir, just because there was no alternative and nothing else really worked.
Yeah, got it. And any thoughts on your side, Clement, for relating to kind of the trends that we've seen now focusing more towards privacy?
So I think that technology is maturing. As Sylve said, I think that as far as I can tell, at least on our side, we basically are able to do very efficient client-side proving, because also we leverage Stu, which is which has been like released in prod version maybe 5 months ago. So I think Stu has been started in 2023, and it's been 2 years ago released production ready wise. So I think it's just like the provers have evolved, the technology has evolved. The Star prover, which allows easy implementation of general purpose zkVM, as far as I know, at least, updated their performance quite a lot in the last 2 years with the introduction of small fields. The libraries themselves have evolved. It's not only Kakarot, but I don't want just to say that we are the best. That's not true. And I really like, for example, OpenVM. They are doing a really great job. It works very well as well on client side. It's based on Plunky tree, but the the stack internally is very similar in terms of the proof system they have built. The library is not the same anyway. So I would say that the demand was here, as we see, because from the very beginning, the initial ideas were using zk for privacy. But then the solution have not initially faced this demand, but another demand, which was the scaling of Ethereum. But at some point, scaling Ethereum has made the technology mature, and the technology maturing, we go back to the initial promise. And not also, to be completely fair, that we talk about zk, but most of the zk system nowadays are not zk. And if our Ligatron people hear this podcast, they will say, okay, thanks, Clement, for mentioning that we are the only one to be zk nowadays. No, but I mean, I don't want to say we are zk. Well, it's not true. If people listen, they need to know that most of the zk system today still needs to be updated to actually be zk, like means zero knowledge. Ligatron is one of the, or dearly, I think, nowadays, that is actually zk. Noir is zk. If you do circumfix, you can do zk. But if you use this modern solution I was mentioning just before, then it's not zk yet. There is a road, there is a path to do it. So it's not a blocker. That's why, generally speaking, we just say, okay, it's zk. We will do it at some point. But yeah, as we speak, it's not the case. Anyway.
There was a whole debate on the zero knowledge Telegram chat by, I think, a Zcash developer. And she got angry and said, no, we should call them zkVMs because these are the only zkVMs that are actually zk and have the zk property. The other are, I think it was also Elie Ben Sasson, probably 3 or 4 years ago, that got really mad on Twitter and said, we shouldn't call them zk rollup, we should call them validity rollups. We only verified the validity. These are not zero knowledge. Indeed.
But it's called, I think officially it's called validity. I mean, if there is an official term somewhere, it's called validity rollup. And very recently I was reviewing a marketing content in my writing, and someone put the zk rollup. Say, okay, no, if we want to be exact, it's not zk rollup, it's validity rollup. But then I type it on Google. So many people are using zk rollup that I think, okay, you know what? Put whatever you want.
I think we lost. Okay. I think we lost that battle. Elie lost that battle.
Yep, I remember even like for the proofs as well. People were saying we need to stop using the term zk proofs. We need to use validity proofs instead. Of what you're trying to prove is not, you're not trying to hide any kind of like private witness data. If you're just trying to scale the proof, then it should just be called validity proofs. So there's been quite some debate in terms of the terminology. And yeah, definitely really liked the point you made, Clement, about how, you know, the demand was here and then the technology matured, especially on the scalability side. And a lot of teams, for example, right now are working on accelerating towards the real-time proving, and that has made a lot of our systems more advanced. And now we can go back to our original privacy-related focus. So it's really good how we kind of made that circle there. And Sylve, to your point also, we've seen that shift you mentioned from the cryptographers to developers. Before, you needed to have PhD in cryptography to even use zk, and now if you're a developer, we've made our systems developer friendly enough where people who don't have these cryptography or backgrounds can still use zk and integrate it with their applications. So we've seen quite a few different shifts there, especially on improving the developer experience.
I'm doxing Clement, but this man has a PhD in math, so the bar is still pretty high.
Yeah.
I'm not gonna lie.
I do.
Yes, pretty high indeed. But hopefully one day we can have zk be used, even like our grandparents can use it.
But but it was becoming too easy to use, so that's why I started a new VM, a new language, because otherwise it was just done. You know?
You just keep them on their toes.
Yeah.
Yeah, definitely.
As part of the development, to come back to your question, sorry I cut you off, Alice.
No worries.
I think we were mentioning privacy and scaling. In my mind, I think the next evolution in terms of user-facing or the feature sets that we're going to explore with zk are definitely going to be around. I've been trying to find a good concept to encapsulate it. I think it would be something like accessibility, like zk for accessibility. You can see some glimpses of it in different projects. You have zkEmail, for example. The first time I tried the demo for zkEmail, I entered someone's email address, I sent them an email, they generated a proof that they got the email, and then they took custody of the funds. It was one of these like, oh shit moment I had in blockchain. It was really, really good. You had zk P2P that allows you to sort of permissionlessly on-ramp and off-ramp money. So you generate a proof that you've sent money to someone through a Venmo, Ramp, or if you're French, Lydia, for example, or PayPal. Mm-hmm. And that's really, really, really cool. And there are honestly no alternatives to zk there. And it's incredible. My hunch, and this is why we're building Hyli the way that we're doing, is that we can really bake in these type of features and protocols at the core of the protocol. Like all of this can be accessible, not necessarily as an opcode, but for a developer, we want to make it as easy as possible to use, so that you're able to send money to someone's first and last name. I have a very Sybil-resistant first name, so I'm the only one who can generate a zero-knowledge proof that I own the Sylve passport, and people could just send money to me, and that is an incredible feature. And if you really want to push the thread for some crazy ideas, you could do a worldwide airdrop, and you could just say anyone who has a valid passport is able to claim a certain amount of tokens. And that is, in terms of scale, that is insane. That is just ridiculously powerful, and that unlocks a whole bunch of features for applications and even marketers. You could do something like a referral scheme. You could just say, oh, if you bring, that's what PayPal used to do or Dropbox used to do. You bring in your friends, you get some additional storage, or we give you $10. You could do the same thing, like onboard another person, and we verify this with their passport, get some token. And that is a very, very powerful feature in order to just make sure that we break down the barrier between Web 2 and Web 3. And to this end, client-side proving is necessary, because you need to have access to these form factors that people have. So that is a very, very exciting development in my mind.
Yeah, absolutely. And really great how you mentioned the zk accessibility kind of phase that we're shifting ourselves into, because for the past decade or so, or more than that, we've just been focusing on developing the infrastructure, getting ready for this new wave of applications that can come by. And you mentioned there's currently, in terms of the accessibility features, for example, there's a zk email, the P2P, even eventually maybe we can even see your example of the world airdrop. As long as someone has a valid passport, a valid form of ID, they can participate. And in terms of scale, that's just encompassing everyone who lives here, which is pretty incredible. So it's really exciting to see that now we have this new shift towards building zk, using the zk infra that we have built and all the research that we've done for the past decades to now be applied into enabling for these new applications to be integrated on top of the infra. So I think it's a very exciting shift indeed, and I like how you phrased it as the zk accessibility stage.
Yes, I think that with respect to this, anyway, in this context, zk can really be seen as just a new generation of oracles for whatever needs to be used on chain. So if I were Chainlink, for example, today, I would be a bit scared if I don't invest in zk, because it's 100% sure that I soon won't need to have a price feed anymore. I will be able to query a list of available price feeds like Binance API or whatever, Coinbase API, validated by the pool or the swap application. I will just submit the timestamped proof from Binance plus my transaction. Why do I need an oracle for this? Why do I need someone to continuously post? Why do I need to pay a link token for this? So I think that really the zk needs to be seen, of course, as a scalability as it's been for the past 5 years, but now completely as a accessibility oracle for whatever you want to use, of course, on-chain, because you want to settle things on-chain, but to bring whatever you want from the outside world directly on-chain, which was, back in the days, the goal of the oracles. So I think that oracles are having a bad time. My bet with client-side proving, oracles are having a bad time.
Yeah, absolutely. And I also wanted to talk a bit more about the client-side proving aspect as well. We've talked about this shift that we've seen with the focus from server-side proving and client-side proving, and there's still a lot of developments on the server-side proving side as well. You mentioned, Clement, about kind of the GPU farming that's going on and people optimizing for like a good GPU orchestration. And then there's also a lot of proving marketplaces being developed, and just the idea of being able to outsource your proof generation to someone else there's been a lot of developments there. But wanted to hear from both of you the trade-offs that come between both approaches. So one with this server-side or outsourcing of your proof generation, but then also trade-offs that exist in the client-side proving side. If there's any kinds of concerns with latency or not having the hardware requirements, things like that. Are there any kinds of specific scenarios where using one approach is more advantageous or makes more sense compared to using the other?
So I mean, maybe I can start, but I think that the paradigm is similar to what has been done for AI. I mean, like you can run on devices AI models that are a bit less performant, possibly, but in some contexts, it's really something you want to do. Or unfortunately, I think that with AI, we have realized that people don't really care when they are asked, and they prefer to have fast and powerful solution that runs on the cloud. I think that I think that for privacy, and if it really relates to own data or own money, it may be a bit different. I'm still not 100% sure. I mean, I myself fully in favor of this, but to be completely honest, are the people fully aware of the importance of doing it? I think that yeah, hopefully, the more leaks there are in the news, of course, a lot bad news, but the more leaks we see in the news, the more people will start to think that there might be a risk in putting everything in remote server. But still, so I was thinking that is it better if you want to scale? I think it's better to get one massive data center. And if you want and if you have a security concern, you are a company and you build your own data center, or you sign a contract with the cloud provider to put the data in a data center in your country. This is how it happens, and no one actually does it on device. I think that zk may change the game, hopefully.
A big change there is probably going to be there are very few. I like what you said about zk being a good overall technology. I like to see it as sort of a pipe. But the thing is, the only thing that can flow through this pipe is attested data, or data that has been signed by a reputable source. So the best example that we have for this is emails. These are signed by Google. I trust Google. I don't have a tinfoil hat on. I'm pretty sure these guys don't mess up their key management system. Same thing for passports. These are signed by the government. I trust these guys. And you have a push, sort of a very slow wave, but it's kind of just advancing, that more data is going to be signed. For example, you have a lot of invoices in Europe that are getting digitally signed. And so once an invoice gets signed, it means that you can permissionlessly just tokenize it. You can put it on chain and just say, oh, so does someone want to pay this invoice, and I pay them 5% on top. And you can do what is called invoice factoring. And the more data is being signed, the more you can just permissionlessly bring it on chain. And I think it's becoming more of a requirement, at least in the European Union. And for anything with digital ID, it's being pushed as well in the European Union with the Longfellow proving system from Google, but also in the US. You now have I think you now have the possibility to have your ID, the driving license, on a smartphone, and that is actually really powerful. Something you could use it in like permissionlessly. So I think that's more of a tidal wave that's coming, because it used to be that whenever you saw something on the internet, you could be sure that it came from a human. Now it's not so sure anymore. So I think in order to also authenticate that it is me calling Clement and not an impersonator, there will need to be more signing capabilities on devices, using them as sort of enclave or hardware enclaves, meaning that there's going to be more data signed. This feeds directly into zk.
Absolutely. And that's a very interesting trend that we're seeing, that we're anticipating more of this data that we're using to be signed. And for that, we need to have more of these signing capabilities on devices. So what you mentioned about these different hardware enclaves to be run on, that's also a very interesting point. And it's really cool to see kind of like where all of these trends are going, and kind of all of the extensibility that zk can offer in these types of applications, not just those that are, say, like constrained to just Web3 based use cases.
But as we speak, I was thinking, so your question was, what would we prefer, client-side proving as opposed to remote-side, anyway, cloud-based proving? And of course, we are saying a big data center, cloud-based proving is probably most efficient, so that's why people have started to do this with GPU farms and so forth. And then I was going into that direction, saying, to be honest, client-side proving, I hope that people will realize privacy is important, but it's still to be proven. With no joke. But so anyway, if we just don't bet on this, I think that there is, I see two possibilities for people leaning toward client-side proving. So either they're privacy savvy, cypherpunk, they want to preserve something. This is one pillar. We have said it exists in the Ethereum community. It might not exist in the 7 billion world that we live in. And the other option is because for companies, it costs less. It's just like it offers features that they can't offer otherwise. And so it costs less. Of course, if you distribute the compute, no one pays for it, because if it runs on my iPhone, I have the iPhone anyway, so I'm not spending this compute, selling this compute to anyone so far. So it might cost less to them if the fines are very high when there is a breach internally, like for Discord, the recent Discord breach. If Discord were fined $100K per data stolen, maybe they would consider investing in client-side proving solutions, because they would know that the fine is far too expensive. So yeah, I would say that either privacy savvy person, or just because it costs less. And I see possibilities that it costs less, either pure market based or also helped with regulatory. But I don't know if the audience is regulatory savvy, so we'll see.
There are good trade-offs that can be already used in production. One project that I really like is Sylve. And what they're doing right now is that they're generating proofs using CIRCOM directly on hardware enclaves, TEs. And I think they're a very pragmatic team. Obviously, everyone would prefer to have these proofs generated directly on the end user device. But as you were mentioning, what kind of trade-offs do you have? We run FibRace together with Clement. We had thousands of different users and thousands of different specs of phones. And we could see so much variance between the smartphones. I was part of, I think, the top 2-3% in terms of proving speed, just because I have a late-end iPhone. But if you are on a lower spec type of smartphone, it becomes much more difficult. And that's the reality that we're in. Most people don't have a high-end spec phone.
But there is I think, if you allow me, Sil, just to add a comment, there is I think the basic way to read this data is to say, oh yeah, maybe 70% of the devices were able to generate proof in less than 4 seconds, for example. But you can say as well, oh, I have the most recent, for all the phone, no older than a year, proofs were generated below 3 seconds. So then you consider on top of that people rotate their phone every 2 to 3 years, for example. So it just means that in 3 years of time, you are 100% sure that any kind of proof will be less than 2 to 3 seconds. So now you can start building with this in mind. It's 100% sure that if today the most recent device is deleted in 3 seconds, it's sure that in 3 years the market is ready, or 2 years. So then it's good.
Agreed. That was one of the cool things that I really saw with FibRace. It's just zk is usually seen as something that you need a GPU for, or something else, and so we really wanted to build something that was playful for just people to prove directly on their smartphones. So I'm quite hopeful that it works this way. But if you want to redo it like today, the example from the Sylve team being very pragmatic and just saying, okay, you know what, let's just chuck these things in a TE and call it a day. I think is cool. And on the blockchain side of things, you also have the difficulties. The reason people still use the same proving system is because it's very cheap to use on Ethereum. And so you're also really constraining. So it's a bit like you have a very, very fancy machine, and then you use like outdated tech at the end of it. Oh yeah, we just need this one bit. There's this meme of like one guy doing like 35 different backflips on a skateboard, and at the end of it, like slamming his face on a stick. And it feels a bit this way for proving tech. It's like, oh, we have like super advanced tech, like, obviously incredible. We use like double Plunky 3 on Starks, and at the end you always have good old Gross 16 coming in clutch, just to make sure that you have to recurse everything. And I think we're gonna see more exploration towards this. That's what we're optimizing for at Hyli.
Yeah, definitely. And I also wanted to talk to you more about the FibRace initiative that the Kakarot team and Hyli had. And it seems like it's very exciting because you provided that kind of gamified experience that can extend to a lot of users, not even those who are, say, like, who are crypto native or like zk native, but even to the general audience, it seems like they can participate as well. So curious to hear about how you see this campaign applying to just the broader context of being able to benchmark the client-side proving on mobile devices. And then also I'm curious to hear about some of the results that both of the teams have seen. So you mentioned, Sylve, about the variance you saw between the different smartphones and how the lower spec ones, it's a little more difficult. But Clement, you mentioned that if we compare this to the speed of development for these devices, that means in just like a few years, this can be very compatible for just a larger scale of people. So I wanted to hear more about some of how this applies to the broader context as you both see it in terms of benchmarking for client-side proving on mobile, and then also any kinds of particular results that you saw or any kinds of takeaways that you guys got from this.
I don't know, but it's one of the, I would not say a takeaway, but now we talk about FibRace and the things that we have seen while doing the FibRace. So I would definitely not people putting their phone in the fridge to, to make sure to make sure that it can. So the technology is ready. TM, it's ready, and some people discover what it means to run a cluster of computers that something running with a heavy loading. So they put it and I myself did it. I forgot it in the freezer actually. So then I needed to pause it for 3 hours at least, so that because when in the freezer it's really wet inside, so you can't switch it on again directly. So. Yeah, all these kind of things that when you read in the article, data center is down for some reason or burnt or whatever. It's not the cloud and it's somewhere a machine running and it's hitting. And if you do it on your own, at least you've done this. I mean, anyway.
I was using an ice pack, so the risk was reduced, but it's still pretty good to have a cooling system.
That being said, in terms of numbers, so for example,
FibRace. What was FibRace?
Yeah. Yeah, we can talk about FibRace. So FibRace initially, the idea started, I think, in July. So basically, we had our first release of the zkEVM zkVM, and the benchmark were really, really great. I mean, and we prepared a small demo application for LCC in Cannes. We wanted just to show them, yeah, look, it's live, and this demonstration was, of course, doing Fibonacci numbers because everyone starts with Fibonacci numbers. And so. I don't know, at some point, talking with Sylve, Hyli was having the testnet 2 phase or 1, I don't remember anyway, 1 or 2. And I think that at some point I heard that we are short of proofs. Proving networks are not proving fast enough. I don't want to put the blame on 16th network or Risco Zero, but I've heard, I think, that they were not able to prove enough proof, so that Hyli was not stressed enough. Not enough proof. So I said to Sylve, you want proof? Let's just send proof. We are going to send you proofs. You will see how many proofs you can digest. And it started like that because we had the application. So we just did a bit of marketing for the application. We put this everything in a game, so a bit of game design, of course. And Hyli needed to reboot a third testnet. I suspect they wanted to make sure that it could handle the load. So they made some work because they were scared of us sending lots of zkEVM proofs. And then the time to integrate the prover, and then the holidays. Oh, so it was for September. And I
It was
think
really
that
cool.
at the very end, we have seen like 2 million plus proof, which is, uh, I'm not sure about the number, but at least 2 times more than the number of proof you had for the previous session. Still, 2
Yeah.
point something, 2.2, or generated by no prover networks, just devices like 2,000 users or 2,000 type of devices. Yeah, so I think with respect to this, the comparison with prover network is really meaningful for both settlement layers and number of proof generated. Of course, the prover network they prove lots more a cycle, I would say, but in terms of user operation at the very end, it's also interesting to see this.
It was cool to see. I was pretty happy that we managed to build like an actual fun thing to do, because you always hear, oh yeah, we can do so many Fibonacci numbers, and it doesn't really make sense. So I'm really happy that we gamified it, and we looked at the first version of the application with the Kakarot team, and we said we need to have like rarity levels. And so the bigger numbers were more difficult to prove, and so they were a bit more difficult to get. So it was cool. I was completely hooked. Like I had my phone on the whole time. It was completely draining my battery. It was really cool.
Sylve, do you think that the KROM cards are becoming the CryptoKitties of the ZK proof?
It's been a long time that I've been saying, oh, we need a near
NFA,
for ZK.
NFA,
At
do
least we
your
have the
own
NFT
research.
now. Now we have the NFT standard for ZK, so I'm happy we've done this.
Yeah, very happy to
Yes.
see the results too. And just based on this, would you guys say that we are ready for client-side proving? You mentioned that there's around kind of 2,000 different types of devices that kind of participated in this campaign. Would you say based on the results that you've seen, are we ready for client-side proving? Are there any other types of bottlenecks? I don't know, say with, for example, memory consumption, in addition to proving time, that we need to address before client-side proving becomes more mainstream?
Yeah, I mean, at least in terms of memory usage, there is a clear, at least for the stack provers that we use nowadays, a clear limitation in terms of available memory. For example, the KROM prover is not running if the device has not at least 3 GB of memory, which is, for example, something that is not the case for the Longfellow Google Wallet thing. So they have worked towards solution allowing provers with as few as a few dozens of megabytes of memory. There is a good PSC privacy scaling solution from they changed name recently anyway. The PSC team, the Ethereum team, they are doing benchmark for client-side proving solution, and now they are about to release their quarterly update. So it would be good to see the numbers. Anyway, yeah, for sure there is this clear limitation in terms of memory available for the solution that we are building. That being said, I don't think that's going to remain a big blocker either, because both the devices are going to have more memories, because you can start to talk to the market with just a subset of the market. And as I've said, people are rotating funds every 2 to 3 years. Maybe the US, they are rotating fund even like um, sooner. And also, I think that the provers themselves are about to optimize in a way to this memory usage. And I also think that for off-chain usage, the whole zkVM things might be a bit useless, and you will just embed the circuit directly compiled, which will also reduce the overhead of the runtime and the overhead of the proof itself. Yes, so for example, the interesting fact from the from the FibRace about the proof size, because it's not only the RAM of the phone, but also if you are using a network which is like not Starlink or whatever, most of the time the upload bandwidth is very limited as opposed to the download bandwidth, and no one noticed because you can download. Most of the time you download, you don't upload. But then if your proof is like 3 MB, the uploads might take up to 7 seconds or something, 10 seconds if the network is not really good, if you're at 4G. So in terms of sort of proof size, there are things to be done. And then anyway, I think lots of engineering things can be done to make this fit in a year, to me.
I guess the tooling works really well for an actual application, for a smartphone application. The part that is still, to us, like the white whale, like the part that doesn't quite work at the moment and will need to get better, is anything happen that proofs generated directly from the end user's browser. I think that it is still very difficult. You have a lot more memory constraints. You can't bake in a lot of the things that some of the tricks that like Clement mentioned, like baking the circuits directly into the app. It's still quite difficult. So we run a benchmark last year with Vlad, who's a cryptographer. We told him, okay, look at all the proving schemes that exist and do one thing. You need to prove the signature of a P256 signature. That is the type of curve that is used for passkeys and these sorts of things. And he's looked at everything, like Halo 2 didn't compile, Circum, the proving key was too big to fit in the browser in local storage. So Noir was the best option. Now we also have Cairo M and Ligero, so we need to have him update the benchmark. But I think the next level is really to make it as easy as possible to embed in a web application, not only on a native smartphone app. It works, that's absolutely for sure, but there's still quite a lot of work to be done on the packaging side, making sure that it's as easy as possible to drag and drop into a web app. Just like we don't have a rainbow kit for zk. That's the thing. If you want to do anything with wallets on a web app, it's very easy. It's still not the case for zk, but we're getting there.
Mm-hmm. Got it. So not just on the kind of the mobile or the app side, but also on the browser-based side, so any kinds of applications on the web. And I feel like we've seen also a lot of improvements with like WASM-based verification or just the browser-based verification developments happening. So really exciting to see that we have some, like on the verification side, some alternatives to just the on-chain based verification. So we're definitely seeing a lot more kind of flexibility in terms of the ways that people can generate the proofs and also the ways that they can verify them as well. So both really great points that you mentioned, Clement and Sylve. And then I also wanted to talk a bit about implementation diversity in our zk stacks. I know for both Hyli and for Kakarot, you both are very focused on providing this modularity and also this diversity. So for Hyli, I know there's the diversity in the proving scheme implementation. So Sylvie mentioned that, for example, in addition to integrating with multiple verifiers natively, including the Cairo M1, you guys have also been looking at supporting some other zkVMs and other zkDSLs, including Noir, and in general trying to support like a variety of these different proving schemes. So curious to hear from your end what advantages this has in terms of modularity, in terms of this types of integration. And for Clement, your side with Kakarot, curious to hear how Kakarot can help make Ethereum more safe with this independent stack. And I know that Kakarot consists of like multiple different proving approaches and really embraces the concepts of multi-proofs. So curious to hear from your end as well what advantages lie in implementing this idea of implementation diversity within our zk stack.
I think there's definitely beauty in diversity, and what we've seen specifically it used to be that one specific blockchain ecosystem had one single proving system. You're on Stocknet, you use Cairo. You're on Helio, you use Leo. You're on Mina, you use O1JS. And some of these languages have advantages that others do not have. Even basically to the two big families are: is it good for a server-side application or is it good for client-side application? zkVM's on the one side and Noir and Cairo M on the other. But even between them, they have differences. Some of them are much better for, like OpenVM is really good, or Pico is really good for ETH proving. And some others are really good for like very specific type of applications. SP1 has precompiles for BLS signatures, for example. So you really want to use the right tool for the right job. And so that's why we really wanted to have the right, just to open up the zk toolbox to all builders, because you could just say, okay, I want to build my app, 95% is Rust, 3% needs this weird precompile from the zkVM, and the rest has to be privacy preserving, so I'm going to use Cairo M. And so we really wanted to provide this diversity. And also because, to what you were asking, Clement, it also allows us to have like an application that requires several proof systems. You could say, okay, it's still early in the zk space, we still find soundness bugs, so you could say, okay, I need 2 out of 3 proofs coming from these 3 different proving systems. So yeah, that's why we actually need some good diversity from proving systems.
And you can have several proving systems, but implementing the same proofs at the very end. You could request lots of people to implement the exact same protocol in whatever language or libraries, and you could still have one single verifier. The idea of having several verifiers, and I was thinking about this as we speak. I mean, the maturity, I think, nowadays of the ecosystem is not yet here for you to say, I just want to support one single verifier. But with the time, I mean, it would make sense. I mean, it would probably make your life easier to have one single verifier and just say to people that they would need to have the proofs, but from different sources. I mean, yeah, I don't know. I was thinking about this as we speak. I mean, as a layer doing mainly verification as you are, basically you want just to make sure that the user has an intent of making a state transition and that this state transition is legit. For this, you require proof. Or if the state transition is sensitive, maybe you want several proof, but it doesn't mean that you need several proof system, actually. So maybe at some point you will update to get something smaller.
Yeah,
Easier to manage.
we just need to see where the market goes, and what we could see right now is that there really is a plethora of different options for zk, and you need a racetrack, like if you want to actually build something that works. So next week we will be releasing a cool demo app we call it Cache. Cache in French means hidden, and it's I think the most lightweight, a very very lightweight implementation for privacy private tokens. And so we leverage Noir on one end because we're quite familiar with the stack, and a zkVM for some state transitions because these are not privacy sensitive. So I like to. It's a bit like Coke Zero. We can just get all the flavors from the zk systems and none of the hassle because we leverage their strength when it makes sense.
So, for example, you generate SP1 proof that you verify the Noir proof, and then this is what you broadcast.
We generate a Noir proof that the UTXO that you're spending is like legit, and we use an SP1 proof to update the Merkle root because this one just has a commitment, so there's nothing privacy preserving there. And so we realized that, oh, actually that's pretty neat because otherwise it requires a very, very big computation to be done on the end user device, and it's just way too much. So we said, okay, what can we outsource to, as you said, 150K GPU clusters? These are really good. So it's
But
kind
I
of an
think
alloy.
that the hybrid approach really makes sense. You do on device the strict minimum just to make sure that you preserve the privacy. If it's what you care about in this application, is what you care in the other application maybe. Anyway, you do a strict minimum and then you broadcast whatever. It's encrypted and no one actually knows what's inside. Uh, Definitely makes sense.
Yeah, we're pretty proud of ourselves. Not gonna lie.
Yeah,
But
definitely. You
our,
should be proud of yourselves. Yeah.
this is I was discussing with a FHE company. You know, there are a few FHE company around, and talking about this ID solution, for example, because zkID, we have talked about zkID a bit before. We say, okay, you generate a proof on your phone that you have a passport, so that you have a majority age or whatever. So because we think about zk all the time, we are like zk is the only solution to do this. He said, man, zk is absolutely not the only solution to do this. What you do? I tell you with FHE, you encrypt you you encrypt on your device your age, and then you just send your passport encrypted. They verify signature and whatever because of FHE, the math still apply, and they just verify whatever, but the numbers they don't know what they means. That was okay. Maybe it's correct. Anyway, I think the hybrid approach of doing a bit on device and other things in remote servers definitely makes sense.
Yeah, and it's great that both teams are really providing that flexibility to different users depending on the type of application they want to build. You guys both have the availability for making it to client side, but then also at the same time integrating with these multiple proving backends or verifier systems based on what the user wants, what they're looking for. I think it's really important, especially as we're going through this next wave of zk-based applications, and different applications have different needs. So it's really great that both teams are trying to accommodate for that by providing this developer flexibility. And just as a kind of like a last question before we end today's session, just curious to hear from both of your guys' ends if there's any kinds of updates you'd like to make on behalf of Hyli or Kakarot, how any developers in the audience can get involved. I know, Sylve, you mentioned about the demo app on Hyli that's going to come out next week, which is very exciting. But just like any other kinds of updates or announcements that you'd like to make.
That's about that. We'll be in Argentina and for DevConnect, so looking forward to connect with everyone.
And on my side, so I released today a new precompile for SHA-256. So as it might have been a bit clear during the podcast, so Kakarot was mainly focused on building EVM things, and during the past 6 months, we have sort of moved to privacy preserving or privacy enhancing technologies, still in the Ethereum ecosystem, of course. So that's why, for example, we spend a bit of time, like significant time, to implement this most optimal, I think, SHA-256 ever precompile. So be ready to hear more about privacy preserving solution from our side, I would say.
Yeah, sounds great.
Confidentiality overall, yeah.
Sounds great. And thank you so much for both of you for joining. I really loved how this discussion evolved from talking about, when we were speaking about the new stages in our zk-based development, how we kind of shifted our focus from privacy-based to scalability-based, based on server-side computation, and then going back to our origins with client-side. And Sylve mentioned about our zk accessibility stage, how all these new applications can be enabled, including those that are privacy-based, and some of the trends there. So I really enjoyed this discussion just on like a high-level perspective of how things are playing out in our current landscape, and also really great to see the collaboration between both teams from Kakarot and Hyli, and how you both are looking at client-side proving today, and how we can go about with not only benchmarking the results, but from that, taking it forward and seeing what other kinds of bottlenecks we need to address before we can truly make this more mainstream. So really enjoyed this conversation today, and I really appreciate both of you for being here.
Thank you, Thank you, Thank you
so much.